Good afternoon, everyone. Thank you for staying late. One of our last sessions here. And pretty excited here to talk about the Data Steward Studio service that we talked about at our keynote this morning. So for those of you who were there, this will be more of a deep dive into that and how that helps with providing context on sensitive data. So my name is Srikant Venkat. I run product management for Hortonworks for the security and governance products. So that includes Apache Ranger, Apache Knox, Apache Atlas, platform security, as well as the Data Steward service that you saw this morning. With me is Ashwin Rajiv. He's part of our engineering team and one of the core key team members on our DataPlane team. So we thought we would give you guys a little bit more of an insight into what we have built so far with DSS, how it's architected, what problems it tries to solve, all in the light of finding and understanding what could be your crown jewels across multiple data lakes. Okay, so with that context, let's get started. So today's data problems are what we are terming as the next generation of where some of the data lake problems arose in the past few years. So we have very heterogeneous data sources, a mix of big data, traditional data sources, so your data is spread across multiple contexts, multiple clusters, multiple platforms, and then you analyze data in different ways. You store and analyze data from different systems, whether it's ERP, CRM systems, other IoT, mobile, etc., and then a variety of channels, social media, geolocation, all types of data coming in. And then some of your data may be on-prem, some of it is in cloud, some of it is in multiple clouds or hybrid clouds. So you want to be able to move the data and move workloads across those. So for all of these problems, the challenge is around how do you identify data, the right data, and then make sure you have the right protection around it, and make sure that you have visibility around that data so you can put the right policies in place, for example, with regulatory contexts such as GDPR. So here's an example. We kind of briefly touched upon this in this morning. The idea here is we have multiple clusters for this entity. So let's say there are clusters spread out all over the world. There's some in Europe, some in US, some in Asia Pacific, and there are some in the cloud. Wouldn't it be nice if we had a fabric that is aware of these data sources? It can enable new types of data services and can also provide a common security and governance model. So that is what our DataPlane service offering is all about. And one of the key services there is a Data Steward Studio that we will talk about in the rest of this, and how that helps you find and analyze data and attach different types of metadata annotations, whether they be statistical or whether they be sensitive data types of annotations, help you discover that, manage that, and give you sort of like a 360 picture of all of that data across multiple data lakes. Okay, so it's not something that we invented. So there's the validation from Gartner, for example. So they call it the data fabric. Forrester calls it data fabric. Gartner calls it data mesh. Essentially. So the idea here is to bring these big data sources and together from processing perspective and also from a data inventory perspective, so you can get all information about the full context of the data, the structure, meaning, origin, lineage, all of the things that you want to have that helps you with the regulatory context on this. And bringing these together with not only just plain Hadoop, but the entire ecosystem and Hadoop and friends, as we call them, to deliver a unified and trusted comprehensive view of all of the data across your enterprise. So with that in mind, we had launched our DataPlane service on the Hortonworks side. DataPlane is a 100% open source product that is going to, all of the component services that are going to be put in there are going to be 100% open source. The repositories are actually being built as we speak, so they will be available in the next couple of months in terms of open source availability for the rest of the community. We think of DataPlane as a platform that provides holistic data management. So what we mean by that is we can address security and governance types of issues comprehensively across the enterprise. We can provide a consistent model for all of that, and then we can enable at the same time centralized access and management to all of those disparate resources that could be globally distributed all over the world in multiple clusters, on-prem, IoT, different types of data at rest, in motion. So the picture on the left here kind of summarizes that you have multiple sources. These could be your IoT, on-prem, cloud, multi-cloud, all of the different variety of systems that you see that hold all of your enterprise's data, especially sensitive data, given the context that we have today in the digital age. DataPlane provides you that little piece in the bottom to say what is the data source integration model, and then it also has different services, Data Steward Studio being one of the services, and we also launched another one about which there was a talk yesterday called Data Lifecycle Manager, which deals with replication, backup, restore, auto-tiering, and those other data management type of functions, and provides you a common security control. Again, the security control leverages a lot of our open source projects and investments in Apache Ranger, Apache Knox, et cetera. And then provides you cataloging capabilities, which leverages Apache Atlas, and distills all of that into one fabric on top that can provide a federated view into all of the clusters that make up that. Okay, so what is the Data Steward Studio? So think of this as a suite of capabilities that can help you understand your data better and secure and govern and manage it uniformly across multiple data lakes. And these data lakes could be, once again, hybrid, on-prem, multi-cloud, whatever the context may be in your enterprise. Again, it's also holistically addresses this across at rest and in motion through our integration between HDF, HDP, and the security governance stack that we have as part of that. Again, the key features here, we'll just kind of go clockwise from in this fidget spinner diagram from the top left. The first thing you want to be able to do is to be able to discover and fingerprint your data. So if you don't know where your data is and what the data is about, then you're not going to have much luck doing anything else beyond that, especially with regulatory regimens such as GDPR coming up. Once you've understood the data, located the data, and you know what it's about, then you want to organize and curate the data. So you'll see some capabilities that we've added there that will help you to nicely curate this information. Once you've curated this information, you also need to be able to catalog and provide efficient search mechanisms to be able to retrieve this data as you're processing or as you're using it in your enterprise context. So we provide some capabilities around data cataloging and search. And all of this is moot unless you can have a very well-defined chain of custody and a trusted source of that kind of data. So we provide data lineage, impact analysis, et cetera, leveraging very heavily Apache Atlas. And then at the bottom, all of this will not be complete unless you can provide the proper data security and metadata security. So metadata security is becoming increasingly important. So this deals with cases where you don't want to leak information that you otherwise might have put security policies for through the metadata that accompanies the data. So it becomes very critical to secure not only the data that you have, but also the metadata that goes along with it. Okay. So the statement below that the technical preview available is as of last week. So we actually made the announcements this will be available, generally available in May. So we're working through the processes of getting that out in the next few weeks. Okay, so what are the things that Data Steward Studio lets you do? So you can organize and curate your data globally. What that means is you can classify data globally based on the purpose, what kind of protections it needs, and helps your enterprise actors collaborate responsibly across that. You can understand where your data is, what it's about, cataloging. So for example, you want to do sensitive data profiling, you want to figure out the risk profile of a piece of data, all of those are put into that understanding. Then you can understand how it's interpreted for use, such as your structures, encoding, statistical parameters, etc. And then also have other user-defined metadata, such as annotations. Maybe you have some wrangling scripts that process the data, all of those kinds of things. So that's how you understand where the data is and how the data is interpreted for use in your enterprise context. Then you also need to understand the veracity of the data sources and also how it came into being. So for example, you need to understand lineage and also be able to say, this piece of data, if I touch this, what are all the downstream assets that will be impacted if I do anything to it? And last but not least is the security envelope. So you need to be able to say who can access this data and its associated metadata, and who has touched that data from a forensic audit and compliance perspective. Be able to say that this type of access pattern has happened over this data, and there are some anomalies here, and you want to be able to proactively put blocks in place so you don't expose your data, especially this sensitive data that is considered the crown jewels in your data platforms. So we'll talk through some of the capabilities here. So we mentioned a bunch of them in the previous slide. So we'll start with the organizational aspects. So in Data Steward Studio, the version 1, we are introducing a notion of what is called an asset collection. The asset collection is just, think of this as an organizational construct that lets you group heterogeneous data sources. So you say you have let's say you want to have a concept, you're a healthcare provider, you want to have a concept called patient data. And the patient data manifests itself as structured data, sitting in, Hive tables or HBAs or wherever, and then unstructured data sitting in files, and it could be your X-rays or other scans and other types of data. We want to be able to provide an organizational construct that will let you group these heterogeneous data sources based on how your business uses it or how your business defines it. So you could have, for example, claims data. So you could have claims that is free text, that is claims notes, and you could have other transactional information coming from other systems, and you want to call all of that as a claims data set or a claims asset collection. So you can create asset collections based on metadata, and you can base that on system attributes or contextual attributes. You have a big list here that you can look at. Then you want to be able to search assets based on those sets of attributes, and then combine them, create these collections, and then have personalized views of those collections for the most common functions. Again, you need to be able to delete those and be able to provide what we are calling an asset 360. Think of the asset 360 as a Facebook page for your data asset. Everything you wanted to know about where it came from, what does it look like, what is the shape, who's using it, how have they used it, what security policies are on it, all of that. So we'll talk about the asset 360 in a little bit. So each of the assets within the collection will have its own asset 360 type of page. We saw in this morning's keynote, we were looking primarily at the Hive tables. We're starting with a very well-defined structured context to say we can now view metadata in different forms and also run metadata annotations. For example, we have a variety of profilers that can be run in the cluster through a very flexible, scalable framework that very heavily leverages Apache Spark. And what we've built with the profiling framework is capabilities such as doing column univariate statistical profiling, summarization of audit records, and slicing and dicing the data in multiple ways, as well as sensitive data discovery, which looks at patterning and NLP and in the future other ML algorithms, for example, to determine the sensitive nature of different types of data. We also show in the same views lineage and impact, which we already talked through, and then you can now do a click through into the individual properties of the assets that are part of a collection. Security policy is very critical here, so any of the Ranger security policies that are defined, classifications that are defined in Apache Atlas, all of those get surfaced up in one place. And our intent is to first provide you the read-only view, so you get a consolidated view across all of your clusters. And in the future version, you will be able to take actions that are cascaded down to the multiple clusters from that central location. This way, you'll have one point of control for all of your security and governance activities from that single pane of glass in DSS. Audits and monitoring, again, this is surfaced through summarizations of the audit records. Let's go back here. Okay. And it provides you dashboards of different types of access patterns, so you can understand, who's using it and what are the different types of patterns they are on. Who are the top K users, how many events were there, how many were blocked, how many were actually allowed, and some of the top policies that were fired and so on. So different ways to slice and dice the data around your access patterns, leveraging a lot of the audits that we have, deep audits that we have across the Hadoop ecosystem. The last piece here, which is critical, is that all of this cannot happen in a vacuum, so it needs to be able to provide some capability for data stewards and other data consumers within the enterprise to be able to operate on this, collaborate on this, share their knowledge, and be able to do some crowdsourcing type of activities around that. So we will have abilities to rate asset collections, favorite those, share those, or keep them private, and also have threaded discussions, maybe someone's gone and done an analysis, they've built a model, and they found that this data set is really bad, don't use it, so they can leave an annotation that helps the rest of your enterprise to say, we don't need to worry about that at this point. Okay. All right, so I'm going to pause here and hand it over to my colleague here. So he's going to go, Rajiv he's going to go and provide the technical overview and the deep dive into this.
So hello everyone. You saw in the keynote and also in other discussions, I'm sure also in other sessions about the DataPlane service. And I would like to, before we start on the demo, give a very quick overview of what it is and how it's kind of structured to provide applications like DSS. And so you have a better understanding of what the platform itself is. So in a sense, this is how DataPlane is structured. So the application we're talking about right now is DSS, which is Data Steward Studio, which was also spoken about in the keynote. And that sits on a set of core services, which we call DataPlane core services. And previously you had, when it comes to Hadoop clusters, you have in an organization or a large organization, you might have many clusters. You might have something for marketing. You might have something for sales. And you have a bunch of UIs, and you have, if you want to interact with or find out information about certain tables or certain files, you need to basically log into some application, check it out, then log out, log into another application. And most of the time, your user identity is same across all of these things. So DataPlane basically combines all of this under one layer, one API, one logical abstraction. And you can put all your clusters into it. So in this case, you have 1 to n clusters. These can be clusters running on the cloud. You can have hybrid architectures, some of it on-prem, some of it on the cloud. And all of them kind of get incorporated into this abstraction that we call the DataPlane core services. All the interactions with the clusters is secured using Apache Knox, and they all are kind of tied to this corporate LDAP, which is shown over there. DataPlane comes with its own storage. It is not in the same control plane as the cluster. So it's an independent application, and it has its own storage. It has its own way of connecting to LDAP, and it talks over to your existing clusters or the clusters which should spin up newly. So on a high level, there are 3 parts to it. So you have DSS, which is the application on top. You have the core services, and you have the cluster. And next 2 or 3 minutes, I kind of run through each portion of it. The DataPlane core services basically are a set of collaborative services, so, or you could call them microservices, which kind of work together, and to your organization, they're basically shipped as Docker containers. The content of each of these containers and the applications it contains, it purely depends on the kind of applications we want to use. So for DSS, there is a smaller set. For DLM, there's another set of applications, and so on. Okay, so I made a mistake here. All right, so in its essence, DataPlane core services are REST APIs, and most of them are delivered as services, and some of them. Okay. I need to use the mic. Oh, should put it on. Okay. All right. So most of the services for DataPlane core are shipped as services. Some of them are also provided as libraries. But in a sense, it is just a bunch of RESTful APIs. And what they do is they hide the complexity which is inherent in a large cluster, or when it comes to multiple clusters, they hide the complexity behind it. So every application like DSS essentially gets a very uniform way of talking, security, logging, monitoring, and a bunch of cross-cutting concerns. The most important of them would be your identity federation. So in an organization, if you have multiple clusters, you might have ephemeral clusters which come up and come down. And for these, the single identity of a user, say Joe or Michelle, has to be federated from the application, the screen which the user sees, which is DataPlane, DSS, into that cluster, and that is done, that is one of the key components of what DataPlane Core is. It also provides a lot of auxiliary functions, like it provides audit, it provides health checks, and it provides it for all these APIs which are being exposed by the core platform. It provides a API gateway and a load balancer and things like that. And for application builders, what they have to do is they pick and choose applications. So for example, if you have an application like DSS, it is essentially based on top of Atlas and Ranger. If you have an application such as DLM, which is basically based on top of the DLM engine. So the core services are almost cover every single part of a standard Hadoop cluster. So you have services which interact with Hive. You have services which will interact in the future with HBase and HDFS. And any application builder basically picks and chooses which part of the platform you need to combine to provide such a business application. So the application which we're talking about is the DSS application, and this is kind of a short form of the same diagram. So DSS sits on top of DataPlane Core Services, which sits on top of Knox, and interacts with these three applications from the gamut of applications you can have in an HTTP cluster. And DSS itself is delivered as a bunch of Docker containers. So you have your DataPlane Core Service running. You get the DSS download. It's 1, 2, or 3 containers based on the configuration you have. And just start it up and you have DSS running. So DSS itself, again, architecturally it is using a profiler engine to get sensitive data and tell you what kind of assets are there and who's using these assets. So it has an architecture where you have a certain profiler engine. This profiler engine sits inside the cluster. It has a bunch of jobs it spawns, which we call the data profilers, which run on a compute engine and talk to Hive to provide you this infrastructure. Okay, so that's pretty much it from me. I think we can start the demo now.
All right, so thanks, Ashwin. So the key thing that Ashwin mentioned, which probably is worth highlighting, is that the profiler framework is very open and flexible, so you can write your own profilers and extensions on top. Today, we have an example of 3 or 4 of them that we saw both in the keynote, and we'll look at it here today when we go through the demo segment. So to set up the context, you saw this picture this morning, so let's just go back to our friendly neighborhood, Hortonia Bank. So they have clusters all over the world, so they have 3 data centers in different places. They have in Dublin, Prague, San Francisco, and then they also have data lakes out in Azure and Amazon. They have all kinds of data being ingested from different types of systems, everything from CRM to EMR type of systems, POS type of systems. And then on the right, you have like different channels through which customer data and even employee data is coming into these data lakes. And all of this, again, the problem is, where is all this personal data? So there's all kinds of information here around your like your national identities, your addresses, your phone numbers, your medical information, even your cultural identifiers, which are all now need to be protected properly because of GDPR. So there's a whole mix of sensitive data, strewn around in all of these clusters. And how do you find this? How do you understand this? How do you make sense out of all of this to make sure that you have the right security policies and the right governance around that data so that you can meet any kind of compliance mandate? So let's very quickly go back and look at DSS. Okay, so I'm going to log out and log back in just to show you the experience. So as Ashwin mentioned, the key to DataPlane as a whole is that you have an identity that is coming from your corporate sources that can be propagated into the individual data platforms. And the way that is done is through Knox. So what you see here on the front door is essentially behind the scenes there's a Knox container that is part of DataPlane. And that gives you the ability to do single sign-on, whether it's like via SAML or OAuth or other protocols. So whatever Knox supports in terms of authentication and federation of those credentials into multiple clusters is all leveraged wholesale in this front door. So once you log in this case, there is a data steward called Michelle who works out of the DPO organization. She's based out of Dublin, according to the story from this morning. So She's now logging in. She's looking at this set of clusters. We're seeing she's focused on the European footprint, so she's looking only at the clusters in Dublin and Prague. Both of these clusters are now registered into DataPlane. So the biggest difference that you see here is you don't want to be moving this data between these different areas just because of residency and local residency, other kind of privacy rules that are in place. Instead, you register those. It enables you a common access into all of those data platforms sitting in those different locations. So you can see there's some bit of metadata here about the cluster. Adding these clusters is very, very straightforward. You can add any data lake that you want. You give it the embody URL. You will automatically do service discovery to see what services are running, and you're joined up with that cluster. Once you have connected and you have discovered the services, then you can go in and set up your users and groups, wire this up to your corporate LDAP or AD, and you can set up different services. In this case, the two services on DataPlane, Data Lifecycle Manager and the Data Steward Studio. And then you would need a SmartSense ID, which is your subscription ID essentially for Hortonworks. And you can also do other configuration items around certificate management, et cetera, for how you trust those clusters and how DataPlane trusts those clusters and vice versa. So this is the footprint that you see for all of the data platforms that are currently registered into this DataPlane instance. There are multiple applications like what Ashwin mentioned that sit on top. There's Data Lifecycle Manager, and our CloudBreak product will also become a first-class part of this DataPlane service. So what that means is you have two models. Either you attach this to your existing clusters, or on demand, if you want to fire up other clusters in the cloud and move this data, we provide you the ability via CloudBreak to spin up these clusters on demand with whatever blueprints you want in multi-cloud environments, and also use the Data Lifecycle Manager to move the data from there. And then since this is all wired up, all of that visibility for all of those clusters will come centrally from DSS. So you can look at all the data in all of those clusters together in one place, and we'll see how. Okay, so when the data steward logs in, they have this dashboard of different types of asset collections. And as we mentioned, the asset collections are an organizational construct that lets you group different types of data that is pertinent from a business lens, saying this is the category or this is how I plan to use this data. You can combine different tables, or in this case, tables, columns from different databases, from different locations into an asset collection. So building an asset collection is very straightforward. I'm just going to very quickly run through this. So you can choose which data lake you want to go to. So notice that all the ones that are registered to DataPlane are available, so you can pick data asset collections from any one of those places. Let's say this has PII. And then the rest of it is just a search. You can go and search for any of these. Say you want to do, I know there is a table here by that name. Okay, so just do a search, click add, and then you're done. So essentially, it's a matter of traversing, figuring out what you need, doing the search based either on patterns or on attribute values. So this leverages any of the metadata searches that we have in Atlas locally on those clusters and pulls that up to the context that you have up there. So very easily, you can create these asset collections. And let me just go back here. Then cancel. So the data steward has gone and organized a bunch of these collections. Let's go look at what you can do once you have created a collection. So once you've created a collection, you have what is called a collection dashboard. So in this case, there's a personal data collection in that Prague cluster. There are 5 tables in there. All 5 of them have been profiled. So we have a number of profilers that can be set up to run automatically on your schedule. And in the future, we'll also provide you more levers to add your own custom profilers and also do custom scheduling based on that. You said it one time when you install the agents into a cluster. Ashwin mentioned that you have these agents that run on the cluster. In this case, these are the profiler agents. And when you install the profilers on the cluster, we give you the option to say how frequently do you want to run this. Every 15 minutes you want to run this profile, or maybe you only have a daily ingest, you want to run the profile only once a day. There are certain profilers you want to have running more frequently, like your sensitive data profilers, but there are certain ones like your column statistical, univariate statistics profilers that you probably want to run less frequently. So you can set those independently to run. Then once the run's complete, you will get this nice dashboard of views of different types of data and different aspects of that data that's sitting in those collections. So for example, we have 5 tables in this. All 5 of them profile, 3 have been found to have sensitive data. The types of sensitive data, the occurrences of those. There are, for example, 2 columns here that have telephone numbers, 1 that has social security number, 1 has email, 2 that have emails, etc. And then this gives you the distribution, sensitive versus non-sensitive data. Then we also see, based on the access patterns, by mining the logs in Ranger, we're able to say that these are the users and these are the top users who try to access any of the assets that are part of that asset collection. Again, we can also get some insight into the number of queries and the access patterns and trends of access patterns here. We also mentioned that there are some collaboration features here. So for example, you could rate this asset if you wanted to, and you could also favorite those. You can choose to favorite those in your environment, or you can also collaborate on those. So in this case, I'm going to just rate this, say 4 stars, that gets persisted so people know that it's been added. Then there were, this has not been favorited by anybody yet, so it shows a 0 here. And then we can also have threaded discussion and comments around it. So I can add a comment here saying test collection, etc. So that comment is available to other folks who have access to this collection. Okay, so that's how we construct that organizational construct called an asset collection. Once you have built this, for each of the assets, you'll see the list of the assets that were added to this collection, and you can go explore them in detail. And that's where a lot of the profiling work kicks in. So this is what we're calling an asset 360 page. So it gives you, for example, in this case, a Hive table. So you have the number of rows, columns, how many columns have been found to be sensitive, and you see the lineage picture pretty much looks like Atlas because it is coming from Atlas. And then we have other, the usage patterns around this, so how many users have touched this over what period, and then you can, do different filters here based on monthly, weekly, etc., and your own custom windows. And you also see what kind of operations that they ran on this particular table. On the right, you also see all the profilers that have been run on this and their statuses. And as a result of some of these profiler system tags have been suggested. In this case, this table has some columns that are sensitive data, emails, social security numbers, telephone, etc. And we'll see where that shows up. So there's also a schema view because this is a structured table construct. So here we have a combination of 2 of the profilers giving you this information. So we have, for example, zip codes. Depending on the type of data that you have, if it's numeric, you will see histograms, and if it's categorical, you will see things like pie charts here. So in this case, this is just US data, US customer data, so there's only 1 country there. Let's go look at maybe something a little bit more interesting. So blood types, and then cars, then we have weights. So when it's numeric, you will also see like a box plot and weight distributions around it. We also see in the same pane of glass the security policies that have been defined against this asset. So you can see all of the range of policies here, masking policies, as well as other access policies. And we also see the list of audit events here. So it's this gives you the tail of this. You can page through it and figure out, if you're looking for a specific audit event in that collection. Okay, so this way, what we've helped you do is we saw how you can go without minimal user intervention. You can set up these profilers to run on a particular schedule that will go find out where the sensitive data is, and there could be a piece of data that have classifications like this that are suggested, and then you can actually go and edit them. So the steward can go in here and say, I don't think this is correct, this is probably a false positive or something like that. They can remove this, and the tags themselves will show in a different state depending on whether it's been approved by the stewards or not. So there's a manual curation process. We don't automatically accept all of them. Once the steward takes that action to do that, there's some little bit of workflow around it to say that let's look at this worldwide customers table. There's an example of that. Okay, so if the tags were not approved yet, they would show up in purple, and you can go click those and then make them approved, at which point it gets persisted back into Atlas in the cluster, and any tag-based or classification-based policies will automatically kick in. Then you'll get the right security envelope around it and the business classifications around it. In the future, what we'll also be able to do is now do this from one point of view. So you will be able to do classifications from here, add additional tags from here, have that propagate to multiple clusters through the DataPlane fabric that we have built. And then in addition, you'll be able to also define policies from this one central place. Here you only saw a read-only view of all the policies that have already been defined locally in the clusters. You'll be able to do central policy definition that cascades out into all of these individual clusters together. And then the last piece here is also around dashboards at the cluster level. So we also have a data lake level dashboard which shows you like a big picture view of, okay, here are all the assets that are in this data lake, how many have been profiled, how many have been found to be sensitive, how's the rate of addition of assets into this particular data lake, what's the status of the runs of the different types of profilers, what are the top asset collections that are most frequently used. So you'll be able to now use search filters to say, show me the most frequently accessed assets, or maybe at a column level you may be able to say, or at an asset level you may be able to say, show me the data sets that are joined with each other most frequently. So based on recency, frequency of usage, you'll be able to build collections and also have auto-suggested classifications applied to them. Again, you also see what are the top assets accessed in this particular data lake. These are useful to say, looking at these patterns, you may want to understand, the sensitivity envelope of that through the profiling, and also be able to put the rational security policies to say, I have high-risk data sitting in these things. For example, the customer data, and that already surfaced as, having multiple attributes of sensitivity in parts of that particular data set. So I want to be able to put better protections on them. I want to write more stringent or sophisticated policies around those to be able to govern the usage of the data asset across my enterprise. So this gives you like a, starting from this 10,000-foot view of a whole cluster, all of the assets in there, the sensitivity map of those, and the usage and access patterns of those, to drill down into other asset collections of groupings of those across multiple clusters or within a cluster, and then drill down further into an individual asset to give you the Asset 360 page that tells you all about that particular asset. So we will be adding other capabilities around being able to, for example, schedule these profilers, be able to run them with different mechanisms, and also be able to add your own profiler extensions on top, and also maybe even, say for example, other patterns or other logic that you want to add if you want to detect sensitive data. So we're trying to make this an open framework that you can add your own logic on top to be able to use the profiler at scale running in the clusters. So that's pretty much a quick tour through Data Steward Studio. Let me go back and see. I think that is pretty much the end of the slides. We can take a few questions if folks have any things they're curious about. Go ahead.
My first question is about the footprint of memory for all of this to actually run. So I assume I have an HTTP cluster running on premise, and this one I will run separate, just like I do with HDF. But how big it is, where does it run, and all these things?
It's a very good question. So it is delivered as containers, right? So and there is very little data persisted there. So if you looked at the model that we had, most of the work is done locally. So we are not running the profiler outside. We're running it in the cluster. All the output of that is annotated back into the Atlas locally. So we are actually not persisting all of these things. We want the source of truth to be as close as possible to where the data lives. We are just providing you that view on top. So all the storage that you saw there is primarily around the state maintenance and other things that DataPlane as a platform needs. None of the information, sensitive or otherwise, that's in your cluster is leaving the cluster.
So now, what is the impact of the profiles and the agents on the cluster itself?
Very good question. So we do provide you the ability to schedule that into whatever queues you want. You can have it run as a background job with a certain capacity. You can control what queues it goes into, and then you can also control how frequently you want to profile and what the priority of that is relative to other jobs that you already have. Because we understand that this is additional information you're trying to get about it. We don't want this to get in the way of the regular jobs that are running on the cluster. So all of those will be configuration parameters that will be exposed as we install the profiler agents into the cluster. This question.
Can you describe at a high level, very high level, how the sensitivity profiler works?
What is it?
How the sensitivity profiler works?
Okay, so the sensitivity profiler today, it runs as a Spark job. And it's an optimized Spark job that looks at a couple of things. It looks at pattern matching, looks at NLP. We'll be adding other ML and another base data, reference data, to make those determinations.
Languages and how many encodings are supported?
So we are starting with a reasonable set, which is primarily today it's English. We will be adding other language support over time. What we are looking at is primarily the PII data set plus a baseline of GDPR relevant data. So these could be things like your IBANs. Then we have the 28 member states passports, national IDs, and so on. So we're in telephone numbers across these things. So we're looking at the primarily the well-known identifiers. Some of the softer ones like cultural identifiers, memberships, those will come later because those require more context inspection. They require like machine learning, training, all of those things. So we're looking at ones which are really the simple ones to get to first, and then making sure that we have high fidelity and accuracy around those. So that's been our focus for this first release. Any other questions? All right, cool. Thank you.